Out in the middle of the ocean, a 200,000-ton ship can suddenly stop moving. No brakes, no parking lot, no solid ground. Just water thousands of meters deep, and somehow one piece of steel holds it in place. A ship's anchor. But here's the strange part. Most people imagine an anchor like a giant hook, digging into the ocean floor and gripping the ground. That's not actually how it works. In fact, the real reason ships stay still is far more surprising, and it involves physics, weight, and one invisible force most people never think about. Because if anchors really worked the way people imagine, every cargo ship in the world would drift away. So what actually keeps these floating cities from moving? To understand that, we need to start where every anchor story begins. At sea, how ship anchors really works, and not in the way you imagine. Why anchors matter. Right now, more than 50,000 cargo ships are moving across the oceans. They carry over 90% of global trade. Food, oil, cars, electronics, everything. And every single one of those ships relies on one simple invention. The anchor, a technology that dates back more than 4,000 years. Ancient sailors once used stones tied with rope to hold their boats in place. Primitive, unreliable, but revolutionary, because without anchors, ships couldn't stop safely. No ports, no waiting zones, no offshore operations. And in today's world of megaships, anchors have grown to incredible sizes. Some weigh more than 30 tons. That's heavier than a fully loaded truck. But even that massive weight isn't the real secret, because the truth is, a ship's anchor almost never holds a ship by itself. And the real hero of the system is something most people completely overlook: the chain, the moment an anchor drops. Picture a massive cargo ship approaching a harbor. Engines slow, propellers quiet. The captain gives a simple command: drop anchor. Suddenly, a giant steel anchor begins sliding down the bow. Gravity takes over, and within seconds, 30 tons of metal crashes into the ocean. The chain roars out behind it, link after link after link, each one weighing over 100 kilograms. Hundreds of meters of chain, unspooling like a steel snake. But something strange happens next. The anchor doesn't immediately stop the ship. In fact, at first, it does almost nothing. The ship keeps drifting. Why? Because anchors don't work instantly, and the reason lies deep beneath the waves. Here's a surprising truth. Most anchors don't hook onto anything at all. No rocks, no reefs, no magical grip. So if anchors don't hook onto seabed, what actually holds a ship in place? The secret of the seabed. When the anchor hits the ocean floor, it doesn't latch onto something. Instead, it begins to drag across sand, across mud, across gravel. And that dragging motion is exactly what engineers want. Because modern anchors are designed to do something very specific. They bury themselves. Look closely at a modern anchor. It has two massive curved arms called flukes. These flukes are shaped like giant blades. When the ship slowly drifts backward, the chain pulls the anchor sideways, and the flukes begin to dig into the seabed, deeper and deeper, until eventually the anchor disappears completely under the ocean floor. Now, something remarkable happens. The seabed itself becomes a grip. Mud and sand press down on the buried flukes, creating enormous resistance. Suddenly, moving the anchor requires thousands of tons of force. And that's when the ship finally stops drifting. But even this isn't the full story, because the buried anchor alone still isn't strong enough. The real holding power comes from somewhere else entirely. The chain that does the real work. Most people think the anchor holds the ship, but in reality, the chain is doing most of the job. And here's why. A typical cargo ship anchor chain can weigh over 100 tons. Hundreds of meters of heavy steel links lying across the seabed. When the ship pulls on the anchor, the chain doesn't lift straight up. Instead, it forms a long curve along the ocean floor. This curve is called a catenary. The heavy chain absorbs the pulling force and keeps the anchor being pulled sideways, not upward. That sideways pull is critical, because anchors are extremely strong when dragged horizontally, but much weaker if lifted upward. If the chain were light, the anchor would simply pop out of the seabed, and the ship would start drifting again. So the chain acts like a giant shock absorber. It spreads the load across the ocean floor and stabilizes the entire system. But even with the anchor buried and the chain lying flat, there's still a powerful enemy at work, the ocean itself, because the ocean never stops moving. Wind pushes the ship, waves shove it sideways, currents drag it across the water, and sometimes those forces can reach thousands of tons. So how does a buried anchor survive that kind of punishment? The answer involves a hidden trick sailors have used for centuries. When sailors drop anchor, they don't just release a little chain. They release a lot, sometimes 5 to 7 times the depth of the water. This ratio is called the scope. For example, if the water is 20 meters deep, a ship might release 120 meters of chain. That extra length changes everything, because it makes the pulling angle extremely low, almost horizontal, and that allows the anchor to stay buried instead of being ripped out. It's a simple trick, but it massively increases holding power. In fact, a properly buried anchor can hold forces hundreds of times greater than its own weight. But even that isn't the biggest challenge, because sometimes anchors face forces far beyond normal conditions. Storms. But here's something most people don't realize. Sometimes anchors fail, even the biggest anchors, even on the largest ships in the world. And when that happens, entire ships can start drifting uncontrollably toward shore, toward rocks, toward other ships. And suddenly, one simple piece of equipment becomes the only thing standing between safety and disaster. When the ocean fights back, imagine a massive tanker anchored offshore. A storm moves in. Wind speeds climb past 80 kilometers per hour. Waves rise higher and higher. The ship begins to swing violently around its anchor point, back and forth, left and right. Every movement pulls harder on the chain. Every gust adds more strain. The buried anchor begins to feel it. Mud shifts, sand loosens, and if the load becomes too great, the anchor starts dragging, slowly at first, then faster. Suddenly the ship isn't anchored anymore. It's drifting, and in busy harbors, that can turn into catastrophe within minutes. That's why ships rarely rely on just one anchor. Many use 2 anchors in dangerous conditions, creating a wider holding zone. But engineers didn't stop there, because modern anchors have evolved into incredibly advanced designs, engineering the perfect anchor. Not all anchors are the same. Early anchors were simple, heavy metal hooks, but modern anchors are designed using hydrodynamics and soil mechanics. Engineers study how different seabeds behave: mud, sand, clay, gravel. Each type requires a slightly different shape. Some anchors use wide flukes for soft mud. Others use sharp blades for hard sand. The goal is always the same: maximum burial, maximum resistance. Some designs can bury themselves several meters deep, hidden completely beneath the seabed. And when that happens, the anchor becomes incredibly difficult to move. But eventually, every ship must leave, which raises another question. If the anchor is buried deep underground, how does the ship pull it back up, raising the anchor when it's time to depart? The crew activates a powerful machine called the windlass. Massive motors begin pulling the chain upward, link by link, slowly tightening the line. As the angle changes, the chain starts pulling the anchor upward instead of sideways. That upward force breaks the anchor free from the seabed. Mud releases, sand collapses, and the anchor finally emerges from the ocean floor, sometimes covered in thick layers of seabed sediment. Then it rises through the water, back to the bow of the ship, locked into place until the next time it's needed. But here's the most fascinating part. Even after thousands of years, the core principle of anchors has barely changed. Weight, friction, and clever geometry, simple physics, holding back machines weighing hundreds of thousands of tons. So the next time you see a ship anchored offshore, remember what's really happening beneath the waves. a massive steel anchor buried deep in the seabed. Hundreds of meters of chain lying across the ocean floor. The ship pulling gently against that hidden system, balanced perfectly between gravity and friction. No hooks, no magic, just physics quietly holding an entire floating city in place. For thousands of years, anchors have been the silent guardians of the sea. They allow ships to stop safely, wait out storms, load cargo, protect crews. And without them, global trade would grind to a halt. A simple invention, doing an extraordinary job, hidden just beneath the surface of the ocean. And now the next time you see a giant ship sitting still in the middle of the ocean, you'll know the incredible engineering working silently below it. If you enjoy discovering the hidden systems that keep our world running, make sure you subscribe, because the next story might be hiding in a place you'd never expect. And once you see it, you'll never look at it the same way again.